Students, myself Vishnu Samotya, Faculty of Education and Methodology, Jayoti Vidyapeeth, Women's University, Jaipur. Practical session: Determination of biochemical oxygen demand (BOD) in effluent samples. Students, today now we discuss determination of biochemical oxygen demand. Material and reagent requirement: BOD bottles 100 to 300 milliliters and magnesium sulfate solution dissolved 100 gram of magnesium sulfate is 200 milliliter in previously boiled distillation water and after filtration of these solutions. Next are requirement: alkaline potassium iodide solution. Alkaline potassium iodide solution that is dissolved separately 350 gram of KOH and 75 grams of KI in distillated waters mixed to or make the volume of 500 milliliter with distillated water dissolved separately 5 gram of solution azide and 20 ml of distillated water and mix alkaline iodide and sodium azide solution. Sodium azide avoid due to the organic matters and chloride present in samples. Students, next requirement are sodium thiosulfate solution 0.025 N. Take 6.25 of sodium thiosulfates and dissolve it in the previously boiled distillated water and make up the volume to a 1 liters and add to the NaOH as a representatives and solution is colored bottles and starch indicators. Dissolve 1 gram of the starch in the 100 ml of the warm distillation water and add a few drops of toluene from the form the representatives and concentrated H2SO4 gravity is equal to 1.84 to 18 mg. Student methods: take the glass stopate BOD bottle of a unknown solutions 100 to 300 milliliter and fit to the samples avoiding by bloodings. So no air should be trapped in the bottle after the stopper is placed. Open the bottle and add in the 1 milliliter of the magnesium sulfate and alkaline KI solution using separate pipettes. If the volume of the samples is over 200 milliliter, add and 2 ml of each reagents in set of 1 ml 1 milliliters. Okay, students. So students, a precipitate will appear placed to the stop and sack bottle through samples at the stage can be stored to the few drops and if it is a requirement. Add 2 milliliters of the H2SO4 and shake through the dissolved and precipitated. So transfer greatly avoid bloodings while the content in the conical flask at the 5 drop of the starch indicators and titrate against sodium thiosulfate solutions and note to be the end point regarding with the initial blue colors to the colorless. Initiate blue color to the colorless. So the calculations of a biochemical oxygen demand is equal to V1 N into 8 into 1000 DO milligrams per liter and V2 minus V3 whereas DO is equal to dissolved oxygen V1 and volume of the Triton Na2SO3 milliliters. So the N is equal to normality of the titrant and V2 is equal to volume of the samples and V3 is equal to volume of the magnesium sulfate plus alkaline KI solution add is milliliters. 8 is equal to equivalent gram weight of the oxygen. So the obtained to value of DO in milliliters divided to the DO is milligram by. So the results is given sample are given below. Okay students. So students, ये होता है अपने पास determination of biochemical oxygen demand BDO. Okay, thank you.